I just called principal sir and he told me to begin the program. He will not come today. He is busy with other meetings. Sanchari, you can start now.
Good afternoon, everyone, and welcome to this online event organized by the PG Department of Conservation Biology and the Institution Innovation Council. We are extremely grateful for the constant encouragement from our patron, respected principal Dr. Devnath Palit sir. He could not be with us today due to some engagements, but he has sent his best wishes with us for the grand success of this event. Today, we will be diving into the intriguing topic of technology readiness level, focusing on innovative apps and other digital software for wildlife identification and documentation. This event is designed to enhance our understanding of the application of TRL in wildlife conservation technology. We are thrilled to have you, sir, all and our on speaker and audience, and look forward to an engaging and informative session. Now, without further delay, I would like to invite Dr. Topojit Bhattacharya, Assistant Professor, Department of Conservation Biology, Durgapur Government College, to introduce our esteemed speaker for today's session. Over to you, sir.
Thank you, Sanchari. Good afternoon, everyone. It is my great pleasure to introduce our esteemed speaker for today, Mr. Oloy Das. Oloy is the founder and Chief Technology Officer of Habitat Lens, where he leads the development of artificial intelligence-driven solutions for wildlife conservation, habitat monitoring, and sustainability. His expertise in computer vision, deep learning, and edge AI enables him to create intelligent wildlife monitoring and conflict mitigation systems using low-powered devices such as Raspberry Pi and Google Coral Tensor Processing Unit. Alloy's innovative work seamlessly integrates AI with ecological conservation, focusing on real-time species detection, habitat analytics, and early warning systems. One of his notable achievements includes the development of a conflict animal deterrence device using You Only Look Once version 8, which has been instrumental in protecting both wildlife and communities. Prior to founding Habitat Lens, Aloy was a project linked person at the Indian Statistical Institute, where he worked on scene text recognition and document AI. His research contributions have been published in prestigious conferences and journals, including the International Conference on Robotics and Automation, Winter Conference on Applications of Computer Vision, and Knowledge Based Systems. At Habitat Lens, Aloy envisions a future where AI powered conservation technology brings together computer vision, the Internet of Things, and sustainability to create a harmonious balance between human development and wildlife preservation. Passionate about AI for good, he combines his technical expertise with a creative and nature loving outlook. Please join me in welcoming Mr. Oloy Das. Sir, over to you.
Thank you, Tawajidda. Yeah, you have told so many things about me. Uh, Please present from here. I'm audible.
Yes, sir, you're audible.
Okay. Yeah, my screen is visible now.
Yes, sir, it's visible.
Okay. So, uh, Tawajidda introduced so many things and tell about me. So let's start about the first project we are doing in HL. That's designing multimodal smart NLD for human wildlife conflict and mitigation. So the main thing is while humans stays in the boundaries of the forest, there are so many times some animals comes into that habitat, and there are so many conflicted uh, there are so many conflicted. So there are some property damages will be there, some crop loss will be there because in as far we know in the Bakura side during the paddy season, the elephant came and uh, destroy their fields, and that's the main issue for the wildlife, animals, and the humans. After that, there are some deterrent system like fences, care devices are there, but they are not non-lethal. They can harm the animal. For that, we are trying to uh, s- uh, make a sustainable device so that using AI we can repel them to the forest. So nextly, there are two devices in market available. One is Anidas and one is dog repellent. They use some PIR sensors. That PIR sensors activated on the movement of anything, so that if there is some animal or leaf fall, it will react same. So it doesn't have that much intelligence so that it can recognize an animal or a leaf. So here's a lab. If there some human pass by pass by the device, it will make some noise, and that will be problematic for us. So in our smart energy, we try to make a solar powered AI based animal deterrent system. It has Raspberry Pi to accelerate the computation of AI. We use dual H TPU. It's manufactured by Google, and we have a one GSM module that can send a message, real-time message. And right now, our model can detect tiger, leopard, rhinos, and elephants, and we use yellow GH model for that. So in that image, that device we have made, that device looks like that, and you can see how model can track the animal, like this tiger, his movement, and this leopard, its movement, how it's changed, it's tracking. So the components are crucial because we have to make it too small uh, to move it along with us. So this is Raspberry Pi 5. It's a small computer. If you my screen is my video is visible, in my hand it's the original Raspberry Pi, and it has full power to run a computer like system. After that, this pine board adapter, and the middle part, this thing is HTP. The the need of HTPU and this thing, if I can explain. So when we process a video, because we are taking a one video and processing that video is a bunch of images. So they in a video, if we say 30 fps video, then 1 second of video consists of 30 images. Like that, we process only one images. After that, we do for all the images. When we use that Raspberry Pi for this task, then one image or frame takes 2 seconds to process. So in that case, our we can do some real time concept. So when the animal pass through the devices after 2 or 3 minutes, it will get that detection, and after that it will get send that alert system. For that, to overcome this thing, we use that TPU, tensor processing unit. This thing is not available in India. We order it from Poland, mainly imported it, and after using that thing, we can achieve to make it 5 fps per second. So in 1 second, 5 images can be processed. And this is the GSM module, which is used to send messages. And using this GSM module, we are planning to send message to the forest department along with the forest officers and the villagers. So we can send the message up to 10 people at a time. And after detection, there will be some light and sound so that animal can go back to the forest. And the sound and light will have so many different uh, options so that that animal will not be habituated with that. So future prospects of that project is like we are trying to test it in the real life example. Like we are planning to test it in Sargram, and we are trying to do it. And one more thing that may be possible, we can make a single PCB board instead of so many components, so that that thing will be too much uh, compressed, so that it can be a small thing, so that we can use it as a pocket device, like how Raspberry Pi is small. And for anti-poaching and road safety application, like in the railway, there are so many cases when elephant are run by trains. In that cases, we can alert the stations so that they will be alerted and train will be slow, so that its brake system can work. That thing we can do. And yeah, we can collaborate with so many people so that we can organize it large scale. So next thing is conclusion. In the conclusion, uh, our main target is that human animal through that conflict should be non-lethal. Like we see some videos that when elephant came into the village, they burn it, they shoot it. So in that cases, it will be danger for our ecosystem and our forest. This thing we want to limit this thing, so that we are trying to deterrent them without any harm. So we name it as non-lethal deterrent. After that, our next work that we are uh, doing, and we completed that project and have some paper on that, and it's under review. It's Tricovision. In here we are using computer vision to uh, to perform the Tycho taxonomy. So what is Tycho taxonomy? Tycho taxonomy is like that with uh, the, for mammals. The main feature is mammals have some hair. So using here, we can identify every species. So every mammal has its unique features in their hair samples. In that case, uh, taxonomists use that skill to identify one animal from its hair. Is that taxonomy? And that was a labor-intensive work. And nowadays, when some hair sample is uh, uh, available, they use DNA sequencing for that to identify the species or the animal. In that case, it is too much intensive. So in that case, our plan is to, if we can mm, leverage the labor intensive task and cost intensive task using computer vision. So we have used some CNNs. CNNs means convolutional neural network, and some VITs, vision transformer, to see how it can classify the mm, or uh, classify the different type of hair types according to in between all the samples. Also, we have deploy one interactive tool. I will demonstrate it later in that presentation. So, in that case, we have four taxonomic levels: species, genus, family, and order. So, and our data is collected from Geological Survey of India. It consists of 76 species, and Olympus DX41 microscope is used to capture the images. And there are two examples of uh, images. We have cross sections and another one also. So in that case, our problem is multi-class classification. So using computer vision, we are trying to classify 76 classes. If I uh, clearly say, so there are 77 classes, because as far I can remember, one animal has male and female. I didn't remember its name, and its male's hair and female's hair are different. So in that case, we got that 77 classes. And our input for that program will be microscopic hair images, and our output will be like which species, which genus, which family, and which order. So that's our main target code. So as you can see, it's a huge, large figure. So from that microscopic images, we cropped image from for 500, 512 into 512, and take the important things, important part of the images, and pass it through the classifier. It classify the species, the genus, the family, the order of that hair, that microscopic hair. Here are some results. We have used so many methods and models, and we have accuracies in basis of genus, species, family, and order. And we have that inference time, like that one image to classify one image take that much of time, and that is on milliseconds. So if we can see swing-based model, if we take one image and pass it through swing-based model, it can classify it accurately for species 71.60% in 3.56 seconds per image. So that means that way. If we try to classify its order, so we have that 95.98%. So it's really good. But in that cases, we have four order only. So here the number of classes are less. So the results are too much high. But in species, we classify 77 classes. So in that case, 72.63 is not too bad for our approach, but it's okay and good to us, so that yeah, we can leverage the cost and labor. So as far as I told you in the discussion and insight, easier at order level, harder at species level. And one more thing, vision transformer and CNNs, there are two types of model we currently have in our computer vision system. And here VIT, swing base, swing V2 base, these are vision transformer models. Okay, and rest of them are CNNs. So as we can see, VITs are very good in that type of classification job rather than CNN. One thing is we can say CNN are more older than VITs. That's why it's good. We know, and yeah, it's okay for us. We can use it right now. And with that, as I have told you that cropping methods, we have used that cropping method to uh, cancel out the unwanted part of that images. Yeah. Okay. Now, as I have told you previously, we have made one mm, interactive tool. One second, I am changing that thing. Okay, my screen is visible.
Yes, sir, it's visible now.
Okay. So here we have that interactive tool. I think you all can see that. So here there are some examples already there. So I have used that thing and it will show the results. If I want to upload from my computer, uh, one second. So it's uploading. So when I press in submit button, it will process and it will give that answer. So here, if it's green, then we are thresholding like that. If it's more than 70% uh, confident, then we will color it green. If 70 to 40, we will color it with yellow, and rest will be red. So we have made it for that way, like in that scenarios. But if there need some improvement, we can change it according to their needs. So mm, in that case, our future work will be like that. We are trying to generate uh, more robust model. Means we face that 72% accuracy in 77 classes. But we are trying to achieve more in that cases so that uh, we can use it uh, more practical life applications. And in this work, we face that issue that we have some lack of images. So in that case, if we get more images for training the classification model, then maybe we can get some higher performance for that. It's possible, but I don't know. We have to do that thing, but the for 77 classes, it's too much difficult to get so much images. Maybe because it's a that microscopic image. To take that microscopic image, it's too much labor intensive work. As far I have seen, I am computer engineer, computer vision engineer, but I have seen that process, and it's too much difficult thing. There are so many steps and all. So it might be possible that we can enlarge our sample set so that model can be learned easily. Yeah, that's end of the talk. Thank you. If you have any question, please.
Thank you so much, sir, for that enlightening talk. Now I would make the session open for discussion. So if anybody have any question, um, feel free to ask. Does anybody has any question?
I have one question. Thank you for the wonderful lecture. I
Yeah,
wanted to know that you are working in the identification of mammal using the hair samples,
yeah.
and for that we need microscopic image and all that. So, is it? Are you working only on mammal sample or something? It can be applied in other type of identification also.
Uh, you can use it uh, for other type of identification, but if you want to do it using that here microscopic images, it's only possible for mammals. Okay, so if you want to classify using its shape, like every animal has its different shape, different height, different length. So using computer vision and AI, we can use it to identify.
Okay, so suppose I want to develop one model, and
Okay,
maybe I am interested in outsourcing also. Then
okay.
what should I supposed to do?
For outsourcing what? Means
Uh,
for what thing you want to develop the model or outsourcing?
for example, suppose I want to create one model for identification of some microscopic sample. It may be plankton samples. I hope you
Okay.
are familiar with plankton.
Yeah,
Now,
yeah, yeah.
and same thing, I want to develop one website like that. Then
Okay.
what should be my plan of action, if you can elaborate?
First you have to gather that microscopic images.
Okay.
After that, you have to consider how many classes will be there, means how many types of planktons are there, and how many images are there.
Okay.
Using that thing, you can run that classification model on that. Classification model is so much easier thing in computer vision. You can get some documentation in Hugging Faces. You can run it through it, and it will done your work, and it's done your work. Nothing much difficult for us. I know.
Yes, yes, absolutely. I just wanted to say that for you it might be very easy,
Yeah,
but for people like us who do not have that much technical knowledge, what
yeah,
should
yeah,
we
yeah.
do?
So in that case, you can just collect that data, that
Okay.
images,
Okay.
with the class basis. Means uh, uh, say if I say bicolor is one animal and Indian pangolin is one animal. In
Yes.
the plankton's cases, there will be some here, some name, and I have kept that bicolor's images in one folder and plankton's uh, pangolin's images in one another folder. Like that, I have created that folders with images, and after that, that Hugging Face module have that power to classify it, to train that classifier.
Okay.
Uh, might be too difficult for you, but if you can
That's
give it,
why that's why I'm interested in outsourcing. I wanted to know how I can outsource that particular work.
you can contact Habitat Lens. We are
Okay,
there for
okay,
you.
that's a wonderful idea. That's a wonderful idea. Thank you so much.
Yeah.
One more query I have, that you have,
Okay.
hopefully I have understood it right, that you have developed one website where I can upload the image of the microscopic image of the hair, and by that I can get the idea that of which animal the hair belong to. Now, I
Okay.
wanted to know, is there any monetary attachment with this website? So, or it is simply free?
At this time, it is simply free. that we have developed
Okay.
because it's a testing purpose. We have made this thing, but after that, when we have that much images to train our model full functionally, then
Yeah.
it might be subscriptional based
Okay. So
or
then
something else. And
maybe
we
yes, yes.
at right now we have not think about that because we now at this time we think about how we can solve that problem so that it's that labor and cost we can leverage it.
Mm.
So yeah, for now it's free. You can use it, and that link you can get. If you search in Google Tyco taxonomy, you might get that website.
Okay, but it will be very kind of you if you can share the link in the chat box so that we all can get easily get access to this website.
Yeah, of course.
Okay. Thank you so much.
Thank you. We have two more questions in the chat box. If a speaker allows, then may I put the questions forward?
Yeah, I am seeing it.
Okay, sir. That will be some minimum number of sample size, basically, for the first question.
In that cases, that depends on that number of classes. Means how many types of things you want to classify. If that classification is four, then uh, minimum 20 images per classes is perfect. But if but for diet in stupid highness, can we get some images? So yeah, if I don't know how the image can be gathered, then microscopic images of hair samples. Okay, for orders, if we can go with order, there are four as per now. Okay, yeah, from sketch. I understood. Now I understood. Sorry. So in that cases, 20 images are per classes is enough. Okay. For sorry. If we are trying to gather the order, then for every species, if there are 20 images, then it will be fine. Okay, because order has less number of classes. But for species, how many species you have, that thing is too much required. Means if you have 20 classes and every classes have 20 images, then it will be difficult. Like that, if four orders are four, then for every classes there will be 20 images like that. Then for 20 classes, every pieces need to be 100 because there the probability game plays, and that is too much difficult to classify 20 classes. Understood?
Okay, I have one question. Can I again ask?
Yeah, you
Yeah.
can.
So your model, the same thing is done by Google Lens, isn't it? Google Lens
Not.
take the image and try to identify the which is the species or family or genus. So
Yeah.
how is it going to be better than Google Lens? Because Google will always have access to more images.
Yeah,
So
of course.
don't you think
But
Google Lens will be a better option?
Google does not have that microscopic images access.
Okay, so this is the positive point, the microscopic images that you have.
Yeah, microscopic images is rare because that sample is only have JDSL. We contacted with Kamla Kannan, one of the leading taxonomists in India. So he provided us. But I don't know if Google have that some features, then why people should go for a DNA extracting for that task.
Because maybe DNA checking is much more accurate than matching the image.
Matching that image, then you are saying that taxonomy is wrong.
No, no, I'm not saying. I just
Well,
said that DNA
I'm
analysis will give you more accurate result. That's only the thing I want to
maybe
say.
yeah, it's always better because taxonomy is and because human brain and computer can make some mistake,
Mm.
and we can assume that DNA testing will not make any mistakes. Yeah,
Yeah,
I
yeah,
understood that thing. But
that's correct. Yes, yes.
before DNA testing, in suppose one cases, there are 70 samples we got in some airport. Okay, there
Mm.
are so many images, maybe due to police dog or human hair can be there, and some threatened or endangered species animals hairs are there. During the coaching, they got that hair. So there are 70 samples and it's a mix of so many things, so many hairs, we know. But it's not possible to DNA extracting of 70 samples because it will cost too much. So in that case, using our tool, they can screen it. If it may be threatened animal, if we can say too fast, so that we can screen it like it's an human's hair and it's dog hair. Then you can leave that sample. You don't need to DNA extracting of that sample, and rest of the samples, if we extract DNA extract, we can pass through the DNA extracting process, then we can get that exact result. So in that case, we are leveraging the cost and
Absolutely.
also the manpower. So
Yes.
that's our target. We are not saying that our method is too much good to fail that DNA extraction or taxonomy, but we are that screening. We are building that screening tool so that people that task can be leveraged.
I understand that. That is actually a very good work. I just wanted to know that suppose Google Lens tried to do the same thing, then what is the benefit of this work? I understood that, and in my case also, the plankton that I am planning,
Yeah.
it will have the same kind of advantage.
Okay.
That's something I wanted to understand. Absolutely, it is a wonderful work, and it will save lots of cost and will be much more effective. I understand it very well. Thank you so much for this wonderful lecture once again.
Okay.
Thank you, sir. Um, Anybody has any more questions? Then please ask our speaker, or else we'll close the session. Uh, I would request the participants if you have any
One
more
more
questions.
query, please.
Yes,
Can
ma'am.
we get the contact number, email ID, or something with which we can
Okay.
contact you later?
Yeah, I am writing in the chat box. If you want to contact with me, contact for anything else. Yeah. Oh
Thank you.
yeah. For fasting, CTO at the rate habitatlens.in. Okay. I'm writing again. That dot I am this. So for any query, you can contact us via mail. And anything else?
Is there any more questions?
No,
You
no,
can
no, thank you.
you can either ask or write it down in the chat box, or we'll close the session of Q&A. I would request the participants, if you have any more questions, please be fast. Okay, so I think we do not have any more questions, and our honorable speaker has already provided his contact details. So if anybody has any questions, you can always contact him. Without further delay, we'll move. We are moving forward to the vote of thanks. To deliver the vote of thanks, I would request Dr. Shondip Mojumdar, Assistant Professor, Department of Conservation Biology, Durgapur Government College, to kindly deliver the vote of thanks. Over to you, sir.
Thank you, Sanchari. Good afternoon to one and all who is present here with us. Am I audible now?
Yes, sir.
Okay. Well, good afternoon to one and all who is present here with us for this event of expert talk on technology readiness level, focusing on innovative apps and other digital software for wildlife identification and documentation. On behalf of Durgapur Government College and the Department of Conservation Biology, I feel immense pleasure to take this opportunity to propose a vote of thanks. We express our sincere gratitude to our respected principal, Durgapur Government College, and patron of this event, Dr. Devnath Palit, for his constant encouragement and assistance to organize this event and for sending his best wishes for this event. We extend our heartfelt thanks and gratitude to our wonderful speaker of the day, Mr. Oloy Dash, Head AI Solutions, Habitat Lens Private Limited, for accepting our invitation and to be here with us. I believe that he has enriched our participants with his insightful presentation. We are extremely thankful to him. We are also thankful to all the participants, students, and scholars for making this event a successful one. I also thank all the teachers and non-teaching staff of the Durgapur Government College for extending their continuous support. And last but not the least, I sincerely thank all the members of our dedicated organizing team for enthusiastically organizing this event. Once again, I thank one and all wholeheartedly. Thank you. Thank you so much.
Thank you so much, sir. Before we conclude, I would like to announce that the feedback link is already been provided in the chat box. Kindly fill up the feedback link to get the certificate. You'll receive an auto-generated certificate of the webinar. Thank you so much. Once again, I would like to thank all the participants and our honorable speaker for sparing your valuable time. We'll meet someday again in this kind of an innovative interaction again. Thank you.